Everyone, for today's lesson, we are going to take a closer look at geometric sequences. For today's lesson, I'm going to skip the warm-up, and we're going to do the warm-up actually when I see you guys in class next. So we're just going to hop right into the lesson. So today we're going to talk about geometric sequences. And yesterday, or in the last lesson, we learned about arithmetic sequences. And arithmetic sequences was related to linear functions. So geometric sequences are actually going to be related to a different kind of function, and that function is going to be an exponential function. But in a geometric sequence, the ratio of any term to the previous term is constant, and this constant ratio is called the common ratio, and we call it the letter R. That means that we are multiplying by R, or the same number, every single time in order for us to get to our next value. And R is found by taking the current term that you were on and dividing it by the previous term. So sometimes R can be written as a sub n divided by a sub n minus 1. It's the term that you're on divided by the previous term, and that will give you what your R value is. So we're going to start off by analyzing sequences to determine whether or not it is geometric. So that means that we want to ask ourselves, are we multiplying by the same number each time in order to get to our next value? So analyzing this sequence, I'm going to look at these values, and to go from 1 to -4 to 16, and 16 to 64, I know to go from 1 to -4, I'm going to multiply by -4. And to go from -4 to 16, I'm also going to multiply by -4. And to go to -16 to -64, I'm also going to multiply by -4. And we are multiplying by -4 each time in order to get to our next value. You can also look at the ratios and go -4 divided by 1, that equals -4. You can say 16 divided by -4, that also equals -4. And 64 divided by 16, that equals -4. And 256 divided by -64 is equal to -4. So all of these ratios are equivalent to the same exact value. So in this problem, the answer is yes. This sequence is geometric. And that is because the common ratio is -4 between each term. In this problem, R was equal to -4. So like I said to you, geometric sequences are related to exponential functions. And you might remember what an exponential function looks like. It is y is equal to a times b to the x power. And in y equals a times b to the x power, when it was written in this simple way, a represented our y-intercept, or our starting point. And x represented our multiplier, what we were multiplying by each time in order to get to our next value. So this was our multiplier. So now what we're going to have is we're going to have the same exact formula, only written in a different way that represents geometric sequences. In this formula, we have a sub n is equal to a1, or a sub 1 times r to the n minus 1 power. A sub 1 represents your first term. A sub n represents the term value. And n minus 1 represents your term position, minus 1. R represents, of course, your common ratio. So just like we did yesterday, or in the last lesson with arithmetic sequences, where identified an ordered pair and plugged it in order to help us to find missing information, we're going to be doing the exact same thing. So here is example number 2. For example number 2, what we want to do is we want to write a rule for the nth term of the sequence, and we want it to be explicit. And once again, that rule is going to be a sub n is equal to a sub 1 times r to the n minus 1 power. Then after we use this, we come up with our explicit rule. One of the nice things about explicit rules is that you do not need to know what value or what term came before in order to find your next term. So you can find any term at any point in time using an explicit rule. Then we're going to write a recursive rule. And a recursive rule, remember, that means that you identify your first term, and then you're going to write a rule for that. A sub n is equal to something, some number. So a sub 10, that means that we're going to let n equal 10, and then we're going to have some number as our outcome. So our ordered pairs, instead of it being x, y, is going to still be n comma a sub n, where once again, n represents your term position, and a sub n represents the number in that position. All right, let's go ahead and look at letter A. For letter A, we want to figure out what are we multiplying 972 by to get negative 324, or negative 324 by to get 108. Well, in order for you to figure that out, we're going to divide. I'm going to take my next term and divide it by my previous term. So r is going to be equal to negative 324 divided by 972. Now, because you are going to be allowed to use a graphing calculator on your test, I want to show you a calculator trick just to make sure that you understand everything. I'm going to go negative 324 divided by 972. I'm going to end up with a decimal. It's 0.3 repeating. What's really nice about this is that we all know that 0.3 repeating is 1/3. But you can use a calculator trick, which is where you press the math button and then you press enter twice. Math, enter, enter. And when you press enter twice, you'll get the fraction, and that means that we are multiplying each value by negative 1/3 in order to get to our next term. So r is going to be equal to negative 1/3. And you're more than welcome to check all of the others, but we are multiplying by negative 1/3 each time in order to get to our next value. So now I have my r value, and so in my formula I have a sub n is equal to a sub 1. So a sub 1 represents your first term, and our first term in this case is 972. Times r. Put r into parentheses. In this case, it's going to be negative 1/3 raised to the n minus 1 power. And that is it. You have your rule, and that is step number 1. Step number 2, we want to find what a sub 10 is. So that means we're going to let n equal 10, and we're going to find what a sub 10 is equal to. So I'm going to write a sub 10 is equal to 972 times negative 1/3 raised to the 10 minus 1 power. Because all of this is just simply numbers, we can put this into our calculator exactly as we see it. So into my calculator, I'm going to put 972 times negative 1/3 raised to the 10 minus 1 power, which that's just raised to the 9th power. And I end up with a decimal, so I'm going to use that math enter feature again, and I end up with negative 4/81. And I would prefer your answers to be written as fractions if possible. So I'm going to write negative 4/81. That represents the 10th term. Step number 3, we want to write a recursive rule. So my first term, in this case, is a sub 1 is equal to 972. And in order to get our next term, we're going to be multiplying negative 1/3 times the previous term. So that's going to be negative 1/3 times a sub n minus 1. We're going to do letter B when I see you next. So let's go ahead and go on to the last example of today. So let's look at what we want to do is we want to write a rule given two terms. So the two terms that I'm giving you are a sub 2 is equal to 10 and a sub 7 is equal to negative 320. And in order to write a rule for the nth term, which is an explicit rule, our rule needs to be in the form of a sub n is equal to a sub 1 times r to the n minus 1 power. So there's two things that we need to identify. The first thing you need to do is you need to find what your multiplier is. So we're going to find what r is. Then the second thing we're going to do is we're going to use a point and your r value. Now this point is going to be your choice. There's 2 points that I'm going to provide you with. In this case, we have 210 and we have 7, negative 320. Those are our 2 points that we're going to work with. So we're going to use a point of our choice and r to find the first term, to find a sub 1. Then step 3, we're going to write our rule in the form of a sub n is equal to a sub 1 times r to the n minus 1 power. So those are our 3 steps that we're going to do. Now to find r, that can get a little tricky. There exists a trick, there exists a visual way as well as a shortcut, and I'm going to show you both. So in order for us to find our multiplier, I'm giving you guys the second term and I'm giving you the 7th term. So I'm going to write out what this looks like. So this means that we're going to have some number in the first term. We don't know what that is quite yet. Our second term, that is going to be 10. Our third term is going to be some number. Our fourth term is going to be some number. Our fifth term is going to be some number. Our sixth term is going to be some number. And our 7th term is negative 320. And in order to reach negative 320, we're multiplying by an r value each time in order to get to your next value. So starting at 10, in order to go from 10 all the way to negative 320, I'm going to be multiplying 10 times whatever my r value is to get to the next number. Then I'm going to multiply by r again. So this is timesing by r. Then I'm going to multiply by r again to get to our next number, whatever that is. Then I'm going to multiply by r again to get to the next number. Then I'm going to multiply by r again, and I finally reach negative 320. So essentially, I am multiplying r times itself 5 times. Now remember that r is equal to what comes next divided by what came before it. So what came last was negative 320. And what came before it is 10. So I'm going to divide negative 320 divided by 10, and I'm going to set it equal to r to the 5th power. This is the longer approach for coming up with r to the 5th power and this equation. The shortcut would be to look at your x values. The difference between 2 and 7 is 5. 7 minus 2 is 5. And because of that, we're going to raise r to the 5th power. Now, the reason why we put negative 320 over 10 is because that's going to represent our ratio. And we are looking at a common ratio, so that's the reason why we divide it. It's our ratio. It's whatever comes second divided by whatever came before it. So I'm going to clean up this problem a little bit and make this r to the 5th power is equal to, the zeros will cancel out, and negative 32 over 1 is negative 32. Now, in order to get rid of the 5th power, I'm going to take the 5th root of both sides, or I can raise both sides to the 1/5 power. The 5th power and the 5th root cancel out, and the 5th root of negative 32, that is equal to negative 2. So r is equal to negative 2. So now that I know that r is equal to negative 2, I have just completed step number 1. Now I'm going to use a point of my choice, and personally I like 2 to 10 better than 7 negative 320. And I'm going to use my r value and I'm going to substitute those values into my function, into my rule. So, and this is going to help me to find what a sub 1 is, what my first term is. Now, some of you might say, well, why don't we just divide by 2 and the answer is going to be -5? Sure, you can certainly do that. However, if I gave you, let's say, the 200th term and I gave you the 450th term, could you find what your first term is? You won't want to do all of that work of dividing, going all the way back. That's too much work. So that's the reason why I want to show you this process. So I'm going to write a sub n, in this case is going to be 10, because I'm using the 2 10 ordered pair. So I'm going to write 10 is equal to a sub 1 times -2 raised to the term position is 2 minus 1 power. And I'm going to solve for a sub 1. So I have 10 is equal to a sub 1. And then we have 2 minus 1 is 1, and -2 to the first power is -2. So we have a sub 1 times -2. In order to get rid of multiplication, I'm going to divide. So I'm going to divide both sides by -2, and I find that -5 is equal to a sub 1. Now that I know that a sub 1 is equal to -5, and this is my first term, I can now write my rule. And my rule is going to be a sub n is equal to -5 times -2 to the n minus 1 power. And that is my answer. So once again, you want to identify what your R value is. The way to identify your R value is simply to subtract your X values and to find out what is the space in between your terms. That'll represent your R, what you're going to raise your R value to, the exponent you're going to raise your R value to. Then we're going to set R to that power equal to the fraction of your Y's. Whatever came last will go on top. Whatever came first will go on the bottom. And then we solve for R. After you do that, you're going to pick a point of your choice, substitute it into the function, find what the first term is, and then plug everything into the explicit rule. That is the end of today's lesson. If you have any questions over anything, please feel free to let me know. Otherwise, I will see you next time.